Okay, welcome everybody. Welcome back to the Anarchist project. Today we're going to be working on porting the lighting kit from the old controller board to the new one. And I think I have the old one over here. It's behind. I got a bunch of new stuff delivered, which will hopefully help us out. But basically, I was using this Arduino type board, actually an FPGA, to do this. But we were running into some issues making the memory card work, so I got a new one. Everything you see here is contained in this much smaller board right there. This is called a Teensy 4.1, which has a pretty impressive little micro on it, as well as the SD card slot already built in. So it should be much easier to get working because it's all kind of designed to work right out of the box. And we won't have to do some fancy programming or messing with VHDL to get it to work. Also, this whole thing was 30 bucks, and everything that I just showed you over here cost upwards of 80. So we're already less than half the price on this board, and it's more powerful. So that's pretty cool. Well, we have a lot of things to do tonight, but first, our overarching goal is to get everything that used to be running on that old board running on this one. You can't just hop from one control board to the next, one microcontroller to the next, especially if they're different types, without doing some work. And it's no different here. So first and foremost, we're going to do some experiments with the SD card, make sure that we can read and write to it, as we intend to in the future. And then after that, we will start working on porting the lighting kits. All the lights in the Falcon will have to be moved over, and we'll have to program this in such a way as to control those. And then we'll have to combine those two things together so that we can not only control the lights, but we can also read and write from the SD card. And once we finally do that, we will be able to run the lights on the Falcon without having it plugged into a computer like it is right now. So that's the plan. So hang out, chat, ask me anything, and we will get started. I'll explain as best I can. If you have any tips, suggestions, or ideas, or questions, I want to hear all of them. Because I don't think that everything I come with is the smartest way to do something. A lot of people have given me suggestions that have helped make this project better than something that I could have come up with. For example, the choice of this particular board was helped along by another user that, as I was researching boards, saw the specs on this and decided, hey, this is probably the best choice. So I went ahead and got it. And while everyone's out here, let me know how your Tuesday night's going. I forget what day of the week it is already. Let me know how your Tuesday's going. All right, let's get started then. We'll hop on over here to the Arduino. I've already went ahead and installed the Teensy libraries, and I've pulled up this example sketch, which demonstrates reading and writing to the SD card. So, pretty straightforward. We should take the time. I think we need to up the serial communication a little bit. That starting baud rate is way too slow. So let's do that. And then also, I've noticed from the comments in here that we have to specify the chip select pin that is used to start the SD card. So for Teensy 2.0, it's pin 0 or pin 20 if you get the plus. For Teensy for the Teensy audio board, it's pin 10, so on. It gives you a bunch. And then here it mentions that 4.1, we have to use this constant built-in SD card. So we'll start with that. We'll come down here to chip select and use built-in SD card. That should give us the appropriate one. I saw a forum where somebody was having issues with this, so it may or may not work. We might have to dig around some, but that's part of the fun when you're doing these kind of things. Also, you can just program this through a micro USB cable, which is nice. So I'll get that plugged in. And then I have a SD card over here, which I can use. Let me make sure it's ejected properly. Whoops, apologize. Okay, that folder's empty, so that's good. So everything should be formatted on this, ready to go. So I can plug that in. 128 gig SD card. Hopefully you can read it. I hope these things always there's always the risk that they have a maximum size. So, and SD stuff can be very kind of painful to debug, but we'll see what happens. All right, let's make sure this compiles. Looks good. And this is already awesome. You can see down here that the sketch uses 30 kilobytes of data, of program memory. Our previous board only had 32 kilobytes of total memory for the program. This one, we don't actually compile it that cleanly or that optimized because we actually have a ton of space. We actually have like 8 megabytes of storage, which is insane. So we're using 0% of it, even though our program is way bigger than it was last time already. But rather than using like 50% of it, we're using almost nothing. Also, our RAM, global variables use 45 kilobytes, which is a lot, except that it's 8% of this whole amount that we can use. Looks like we have half a megabyte of RAM, which is also insane and awesome. And our previous board only had 2 kilobytes, so that's already 250 times bigger, which is great. So this should make this way easier to work with and way more powerful. The final thing I wanted to bring up, if I go up here into the tools and go check out the CPU speed, previously we were working with a board that ran at 16 megahertz, 1.6. Now our board's standard speed is 600 megahertz, so astronomically faster, which we were running into issues where we could only cycle the lights so fast because the board wasn't running fast enough. And we can actually see that we can overclock this to 720 or 816, or if we add some cooling elements, if we put a heat sink on it with a fan, we can even get as high as over a gigahertz, which is insane for a microcontroller. So that's really cool. So I'm excited about that. Let's get started. And all right, we've already verified, so let's upload this. Make sure it uploads. All right, looks good. And we have to test it. Oh no, initialization failed. All right, well, anyone's guess as to why. But that's disappointing. I was hoping it would just work out of the box and be awesome, but I didn't want to do it before I got on stream because part of this is letting you all see the process that goes along with this. Where is the limits of Arduino? It won't take me to the definition of this. I was wondering what it is. All right. Well, let me Google some stuff and see if we can figure this one out. Maybe is chip select used in more than one place? Maybe not. All right, well, just for safety's sake, I'm going to go up here and put this right here. Verify that just to make sure. And then we'll upload. SD, initialization failed. All right. So it means it's not getting past this step though. So we at least know where it's failing at. The problem is with the way these things work, it's very hard to tell. We can't really debug very easily, so it's hard to tell what's going on. I'm looking at the forum I was looking at earlier now. So we'll see if we can come up with something. TSPI, just make sure I have the appropriate libraries. Yep. Well, that seems pretty straightforward. Alright, I have this older memory card thing. I don't think I need that right now because I'm basically doing everything the same over here, so I don't need it for reference. Let's just close this out, try it again. There's no reset, unfortunately. Let me unplug this. Sometimes these SD cards, when they're left in like a, when they're powered on already, they don't like to play nice until you power off and power back on. Oh, there we go. Initialization failed. All right, what could it be? It's also entirely possible too that the format of my SD card does not necessarily support whatever's going on. How to format an SD card. All right, I'll plug this in, and if we do have to format it, I won't put you all through the pain of watching that. I'll just start working on something else while I'm doing it. There it is. And format. And let's see our options. Okay. So here are the options here. And I suspect that whatever one we're using is not necessarily not necessarily compatible. Oh, but exFAT is the only one. Okay, so we don't want to use NTFS. Pretty sure it has to be exFAT. All right, well, let's just try a quick format then. Format complete. All right, let me eject that, and then we'll try again. I will unplug this just to make sure we get an appropriate state. Try again. Didn't get anything that time. All right, still failed. Unfortunately, this is a pretty new board, so there's not a lot of data available. So that's why I got to poke around this a little bit. Okay, it looks like, from what I'm reading, that this this particular library does not support the format on this SD card, which makes sense actually because the SD card's pretty big. I don't know if I have a smaller one that I can use. And I think even, let's see, up to 32 gig uses FAT32, which actually should be compatible. So we could try that, or we could just try and make it work with the exFAT system. That probably makes more sense long run, because at some point it's going to be impossible to even buy SD cards small enough. I apologize for doing this off screen. Oh yeah, everything 8 gig and under is pretty much discontinued. 16 gigs still exist, and up to 32s, it looks like, are pretty easy to get. But at some point that's going to go away, so we probably got to figure something out that uses the big SD card, the 128 gig that I have. All right then. Well, let's see what we can figure out. Features. I'm looking at a GitHub that will likely show me just trying to figure out everything I need to do. These SD libraries have to be modified usually for whatever hardware you're running on. There's a lot going on here. How old is this forum? 2018. I would think they would have something sorted out by now for this to make it work. So that's kind of surprising. Let's see here. Cool library. SD. So that exists there. Let's go to, there's a library manager, right? Maybe this will tell us what versions are supported, because maybe I'm overthinking this as well. Bridge SD, here it is. Arduino installed. Once the card is connected to the SPI interface, Arduino engineering, you can create or rewrite anything else with their directories on the SD card. More info. I want to know exactly. Yep, it doesn't support the exFAT system organization. Okay, so that's going to make this tricky. Basically confirmed that our format on this SD card is not supported. I can't format it to one of those older format styles because it's just not small enough. It's too big of a memory card, and I don't know that I have one small enough that I can even do that with. I can look real quick, or I can try and figure out a way around, which I've been trying to do, but it's semi-complicated. But I basically have to download this library written by this other guy and try and make it work. So maybe it'll work? Let's see. If you have any questions or any thoughts too, please let me know. I'm all ears. All right, so maybe I can... Is this installable outside of... do I have to download from GitHub, or can I do it here in this thing? Let's see. exFAT file system. Okay, here it is. Already exists, so let's try that. We'll install it. That might make this a little easier. Alright, and close, and then let's go here. Include a library. And I gotta find it. I think that was the wrong thing. Yep, that's already what I have. Alright, well, let me see if I can find an example on here. Alright, I think I need to comment out this existing one. We'll need the SPI still, most likely. And then finally, and I think that's the right library. Let's just start with this. Oh, okay. We'll have to save this to another location. That's fine. This might work, though. I put a test file somewhere where I did... here we go. How's it going, Beth? We're just trying to stumble our way through a annoying problem right now. Hoping to try and figure it out. My neighbors are doing jumping jacks, I think. Okay. So supposedly this is saved to a new place, so now I'm going to try and compile it. We'll see if it works. I'm not confident, though, that I've gotten this library name right. Built-in SD card was not declared in this scope. Alright, well that's optimistic. Is that the only error that happened? Okay, so now I gotta figure out what that is. Golly. Can't read this on another monitor. There's probably a lot about this sketch that's not correct now, because I think this other library works very differently. Yeah, it was a lot warmer today. I've noticed that all the snow outside my place has melted away pretty good. So that's been nice. SS. Let's see. Okay, it looks like I might define it differently. SD card access pin. Is that a defined constant? I don't think so. There's a lot of options here that I'm working through now. I'm trying to figure out this code. Alright, well let me see if that's an error at least. I can't find where that... I'm looking at an example here, and that's the name they use for it, but yeah, that's a... Oh wait. No, that's... Okay, hold on, that's still an error. That's a keyword. Let's try that one. Okay, that looks like that was the correct one. Now, we definitely have the wrong, like, everything as far as the usage of the SD card, but that's okay. We were moving on to new errors now. And I'm literally going off an example on a forum here, trying to figure out exactly how to do all this. I think I'm basically going to have to... Alright, let's close this down a little bit. Basically take all this out and start from scratch, which is fine. I guess I don't really need any of this as a reference since I have to do it all differently. Well, here. Let's just comment it all out. But keep it around in case I need to look at it. Alright, start SD card. Let's try this. There's a lot of constants that have to be assumed, I think. I don't know that this is the right... Oh, now that I'm reading this, that this SS is the right port. I need to use the built-in. If I include that, then I should be able to use this built-in again. There we go. And now this whole thing I think should verify, because I've commented out everything that was breaking anyway. Okay, yep. That's good. Uses a lot less storage because we took out a bunch of stuff. Alright, we know that we're using... Let's see. Okay, there's another define here that we need. define SD type. We have to say three. Three supports basically everything. So 1 for FAT16 and FAT32, 2 for exFAT, and 3 for FAT16, FAT32, and exFAT. These are all just names of file systems. And since it's on an SD card, there has to be a file system. Okay, so then where does that get used? All right. So while not, and then I think we also have to create a object here. It's the object, and then this is gonna be SD. Okay. And then while not SD dot begin. Oh, if not, sorry, we don't want to try over and over again. We just try and try it once. There we go. Is that right? This example is really hard to follow too. Just terrible spacing and everything. SDIO config. First in, first out SDIO. Okay. Supposedly that does it. And then from that, print line, initialization, whoops, it's a string, initialization failed, else we did the same thing but passed. Except we're gonna make this a little, yeah, let's tab that over correctly. Make this very different. Let's say success. Just so we can celebrate. And then I suspect, let's see, this first in, first out SDIO might actually have to be defined somewhere. I'm not seeing it here yet, though. Let's just try compiling, see what isn't defined. Does not name a type. Interesting. Why is that? It should, because we're including this library, which seems to be working correctly. Okay. There's got to be others too, I think. SD was not declared in this scope, but it was because it was here. Just got to figure out what the actual type is. The scope. Wow, there's a lot of things that seem to be missing. See if I can figure out some usage here. There are examples. We could try that instead. All right. Let's see here. Oh, okay. There's the usage here gets a little weird. Looks like SDFS. Is that right? Nope. It can never be easy. I'm not getting why this isn't defined if I'm including that library. Or maybe it's not. Maybe that's the problem. No, no issues down here. I wish I could open up these files. I don't know where they are though. But I am looking at the GitHub of the project here, so maybe I can find it real quick. Okay, I found the class definitions. I don't know why they're not showing up though. Like, this should be a valid statement right here. But it's saying that this is not a type. Let me see if the issues with this library being included as well. Let me comment that out and then use SS for that. Oh, that worked. Okay, so it has something to do with including this SD card library as well. It causes, I guess, certain things not to be defined here on this include. That would explain a lot. Okay. I think we're getting somewhere. So that supposedly should initialize it. Let's upload it. There we go. And then open this. Hey! All right. Supposedly, we have successfully initialized the SD card. That's great. That means that we're in. We can start reading and writing files. That's usually the hardest part, is that initialization, because there's some a thing called mounting which has to happen, which is a kind of pretty complicated protocol. SD cards are not simple devices. These little memory cards, even though they're tiny, they hold a ton of data in them. And you have to define a file system type. Even on your hard drive, there is a file system type. It's not just when you first kind of have it, it's basically just a big open space. And your computer has to go through and format it and define, okay, this is how I'm going to store things, this is how I'm going to reference them and point to them and create a whole system to do that. Otherwise, you're just kind of dropping stuff off in the wind. SD cards are the same way. They have a whole system, and there's multiple versions of that, because as they get bigger, a system is designed with a certain capacity in mind, and as they get bigger and bigger, those capacities are exceeded, and they devise new versions and whatnot. So with 128 gig, we've gone to the exFAT file system. And then even with that, even though that file system exists there's another layer of programming below that on the SD card, because the SD card has to handle things like bad sectors, when memory breaks or corrupts, it has to save things, and so it has to decide where things actually land in the cells, in the actual physical memory cells. And that's a very complicated thing as well. So there's so many layers that in order to get everything synced up and started, it's very complicated, and getting these things to initialize and mount is a huge pain, at least initially. Once you get it working, and I know I'm going to eat my words here, but once you get it working, they typically work pretty straightforward. Reading and writing files is fairly straightforward. Okay, so now that works, I need to figure out how to actually write a file. So that's a bad example. I need an example where I'm just reading and writing to a file. All these examples on this GitHub are very complicated. Basically just, like data loggers and fancy file readers and that kind of thing. And I just want to know how to do the basic stuff, how to just read and write from a file, because I'll define the rest of it myself. Yada, yada, yada. Card successfully initialized. I'm past that. Oh, this is just getting data, sector counts, and things like that. Okay, bad example. I apologize. I know this is done off screen too, but we're getting somewhere. Oh, here's a logger function. I guess we could try this and see what they do to create a file. It's got to be pretty straightforward, I would think. Okay, we got to create a file object. Oh, actually, we have this, which I'm not sure is exactly what we need. I'm surprised that's still defined, though. Maybe that works. Maybe that's defined in the SPI library, not the SD card library. In which case, that would be defined. Let's see. I'm going to try some of the built-in Arduino functions. Maybe they just work. I don't think so, but you never know. Okay, here we go. Actually, a lot of this is defined down here. We could just go ahead and comment out some of this. All right. Actually, everything below here. All right, I'm excited though. We're on the right track. Okay, so open a file, test.txt, in write mode. Because as you know, when you open files in programming, you have to specify the mode. If you're reading, if you're writing, or if you're doing both. There's read, write, and append. Write will open the file and erase it and just start writing a new one. Read will read the existing file, and append will allow you to open an existing file without erasing it and keep adding stuff onto the end. One of the most useful modes. All right. Write. Am I done? All right, let's just see if this compiles. These functions might not actually be available. sd.open. Oh, shoot. Yeah, we have to specify the specific library here. Let's try that. All right, well, that seemed to compile fine. So this must be the functions we need. I just don't know if the file object is compatible. Let's upload that. And so basically it should write testing 1, 2, 3 to the file and then read that back and print it over the serial monitor. All right, so that's optimistic. Testing 1, 2, 3. It looks like that worked. Let me unplug this and plug it into the computer and see if that file actually exists there like we think it does. This board's getting hot too. Interesting. It's a very powerful micro, but maybe it doesn't have good heat properties. Maybe the trade-off is it gets really hot. Hey, there it is. Okay, this was a huge success. So we have just created a sketch that reads and writes to a file on the SD card on the Teensy, which is awesome because now that means that part is done. We know how to do that. I guess we can use those functions. Hopefully there's a read, there's got to be a read line by line. I think there has to be, right? Those are examples. I'm trying to find. See the read function here. Okay. Interesting. You can read a set of characters, but there's no read line function, like read until the next new line or something. All right, good to know. But this is a huge step forward. And so now what I'm going to do is stop this completely. We know how this works, and we're going to save this sketch, but we're going to let it go. We're not going to work with it. And we're actually go back to our other one that was controlling the lights on the Falcon, and we're going to get all of that working again. So let me save this. And then let's open a recent one. Start memory card. Nope. I'll have to open it. Open lighting kit. This one. Okay. Here we go. And so basically we're going to go here to tools, and our board is already Teensy 4.1. So now when we compile, it's going to go to this new device. But there are some things we have to change because we can no longer use this accelerate NeoPixel library. So that means we have to go through and figure out all the settings to fix this part. Also, we got to get this set up with the wires and everything, so it's a whole thing. So we need a ground and a data. Oh, you know what? It's not that simple either because we need to introduce a level shifter and the whole 9 yards. And I don't know if I got everything ready that I'm going to need there. All right. So I ordered this pack of level shifters. I got like 10 of them for, I mean, they're tiny, but I've gotten like 10 of them for like $6. Some of this stuff is pretty cheap if you know where to look, like Amazon. All right, so the problem is our NeoPixels are controlled by a 5-volt signal, and the Teensy runs at 3.3 volts. So I've had to get this little thing, which is just a transistor that functions as a kind of divide between the two, and using pull-ups you can shift the levels from 3 volts on one side to 5 volts on the other, or vice versa. So that should work. So we're gonna have to go through and put this all together now. And I didn't even think about this part, but all right, cool. Let's get started then. So I'll push this out of the way and let's update our goal because we're going to need that as well. And I got to figure out exactly how to use these. Okay, I think it's pretty straightforward. Ground on each side. All right, we're going to take apart our existing setup over here. All right, I said I was going to update this. I actually need to do that. Build the new circuit. There we go. And then we'll take this all apart and use these wires elsewhere. I'll probably take these out as well so we can reuse them. Yep, I think I'm going to do that. Okay. So this is going to be a whole thing, but that's okay. Let's get started. Let me just, so you can see what's going on, I'll pop over to the big view here. I got a new mount to hold stuff while I'm soldering it. Keep things off the table and make it a little easier to connect things together, like wires and such. So I'm excited to use this. All right. And it's even got a little magnifying glass on it so I can see what I'm doing better, which is cool. All right, let's get this plugged in. Probably not on that side. Get that turned on, and then water on here as well. All right, so I'm gonna take the wires out of the existing board because we don't need it anymore. And once again, try and do this without burning myself. I'm probably gonna let that heat up a little more. The tip always takes a little longer to get hot than you would expect. This board was made in 2016, according to the label on the back of it here. There we go. Next one. The magnifying glass does give a weird perspective. There we go. There we go. Now I have a pinout for the Teensy here, so I can go ahead and pick out a couple of things. I'm going to need a ground. I'm going to need a... Oh, interesting. You can power this thing up to 5 volts. Or no, that's the VN. The actual voltage out is only 3.3. Okay, that makes more sense. Because I was like, there's no way this particular chip can survive more than 3.6 volts. All right, we don't need that anymore. So I guess we need to pick out where everything's coming from. Ground, 3.3, those are pretty straightforward. Let's just go ahead and do that. Unfortunately, the pins on the Teensy are very tiny, so they're going to be a little harder for me to solder easily. It should be doable, but it's going to take a little bit of care. Probably don't even want the magnifying glass for this one, honestly. All right. There's our solder. Fire this up. And then I'm gonna have to, I know that there's a library already in here. Include library. It's called like Octo. Here it is, Octo WS2811. Let's include that. And that particular library is the one that we can use to control NeoPixels already. The guy that made this board basically wrote a library to do it, but it uses 8 different pins. So we will have to pick one of those, probably the first one, and that's the one we'll actually use. There we go. And I'm going to use blue as ground. And then yellow as... Oh no, I got that wrong. I put the blue in the 3.3. That is not what you want. There we go. Yellow and 3.3. And then we'll use... What do we got left? White. I guess we'll use white as data. There we go. All right, and then... I need to figure out real quick. In the future, when I'm doing circuits too, I'll probably need to draw them out beforehand, because otherwise I will be, I run the risk of messing something up. Okay. Let me Google this. Octo WS2811. And just figure out, I just need to figure out what data pin to use. LED strip 1 is pin 2 on Teensy. All right, and it's labeled here, so It is on the other side here, so I've unfortunately done the thing where I make it a little harder for me to do. I should have done the data line first, but that's okay. I'll let this heat up again. It's the way this library is written is so you can use 8 different pins at once to control these, so you can control a huge amount of pixels at the same time. And I think it uses timers or something to, like, it uses a PWM and a timer to run the signal because there is no nanosecond delay, which is an interesting way to do it. I've seen some weird stuff where people came up with weird ways to do that. This particular chip also has something called Flex IO, which is an NXP creation. And unfortunately, I couldn't figure out exactly how it worked, but it seemed like that would be really cool. It's a way to create a custom serial interface through some shift registers, and it's really configurable down to the timing and how exactly it works. So that would have been a cool way to do it. All right, that's good. Excellent. All right, and then on the other side, on the NeoPixel side, we have ground and data. And then we're also going to have to include a new power, which is something new, because we need a reference for the 5 volts. But that's okay. All right, next thing we got to do is get our headers soldered onto this little thing. We could just solder them in place, like the wires into this little board, but we have to connect pull-ups as well and everything, and I don't want to do a ton of wiring dead bug style, so it's just easier if I can drop it into this little breadboard here. It's kind of annoying to have to include it in the project, but it's just part of it, I guess. All right, so let's get started with this part then. And then I'm going to have to use a bunch of solder here. Oh man, there's nowhere to hold on to this board. All the components are so tiny. All right, once again, got to do this without burning myself. All I got to do is not touch the pin that I'm heating up. Probably bend that over a bit. There we go. That looks good. Let me go through and do all the other ones. I've noticed no matter where I lean, the smoke always comes at me from the flux burning off. There's no guarantee that this goes right on the first try too. There may be some more debugging that has to be done. If I get enough donations one day, I'll buy a logic analyzer, and that will make this way easier. Because then I can actually see if anything's happening on pins and what the actual issue is for certain things. If you haven't seen those before, logic analyzers, especially some made by like Salier comes to mind. There's other companies that make them too. It's basically a digital scope in a box, plugs into your computer. Those Salier ones are cool, but they are really expensive. But they're a great way to see what the digital signals look like on a specific wire. There we go. 3 more. Cool. Probably not too hot. Remember to give everything a second to cool down when you're done. Uh-oh. Don't know if this is going to fit very well. Yeah. I'll do my best here. Pins are a little off center. I don't know that I can move it over very easily though, because I have to, let's see here. It's gonna be difficult. No, I don't think I can do this. All right, we'll just see if we can get it to fit in here. There, I think it's in. Sort of, kind of. All right. Now we need this side. Let's see. Blue is going to be ground. White is data. And then orange will be 5 volts. And then on the other side, we're going to have the Teensy, where we said blue is ground, yellow is 3.3 volts, and the white is data. Okay. And then finally, we also need pull-up resistors, because I remember that being a thing on both sides of that. I got a whole bunch of boxes of components I've amassed over the years, but I don't know. I should have resistors, but I don't know what values I have. They need to be kind of low because of our communication speed's pretty fast here. Those are 10Ks. Probably would work, but I think a little too high. Hopefully everyone's doing all right still. I know this isn't the most exciting thing ever, but it's all part of it. .330s are pretty low. I don't think that would exceed the appropriate current draw. These are typically used for LEDs. Let's see here. Anybody remember Ohm's law? So 5 volts divided by 330 gives us 15 milliamps. That's kind of high. Not too bad though. And then the same thing, 3.3 divided by 330 is 10 milliamps. Which should be acceptable for this pin, this output pin that I have this connected to, so I'm going to risk it. I'm trying to err on the side of having... The problem is if you use too big of resistance, the delay and the time it takes for the voltage to go up and down is higher. And in that case, it may be too much. And you may not be able to get any communication. All right, so that pull-up's connected. And the other side pull-up is connected. All right, I'll turn that off. And then I think that's good. We just need to make sure that this gets connected to the 5-volt line here. So we might have to mess with this a little bit. Move this out of the way, so I don't need this anymore. And then don't need this control board anymore. Make sure this still powers up. Yep, seems to connect just fine. There's a tone on my computer that plays when I plug it in. All right, I'm gonna have to stand up and work on this. So just bear with me. All right. I think there is one part I'm gonna have to take apart and fix or change here. I'm gonna have to solder this 5-volt line to these other 5-volt wires. Oh wow, the ground's kind of disconnected as well. That's scary. There we go. And then let me just go ahead and take this off and do it to make it easier. I'll bring this over here. And then try and slide this around some since we don't. I can't slide around too much with everything that's in the way. That sucks. Alright, trying to figure out how to do this without like completely disconnecting everything. Might be able to make this work. I've got to try and do this without melting the Falcon either. That's the ultimate failure here if I do that. All right. Let's get this turned on. Let's cool down a little bit. I'll have to heat it back up. Come on. Whoops. Once again, try not to melt the Falcon. Very important step here. I need to let this heat up some more. Actually, if I get some solder on this wire too, it might help some. So let me do that. Just get as much on here as I can. There we go. Whoa, good catch. All right. Let's try again. I can feel it. I'm gonna get this. All right, I think it's on. Excellent. Now I just got to get this connected back up. Without accidentally tearing off the existing leads. Sorry, my cables are all getting caught in the Falcon. should work. Okay, that's good. Now I just gotta plug these in. Goes there. Goes there. White goes there. All right. That's supposedly all together. Now we got to do some work with this thing. Unplug this since I don't think we need it anymore. Okay. Now I got to find an example of how to use this new library. Octo. Oh, wait, hold on. WS. Oh, I'm sorry. I didn't even have this screen turned over. Let's go back to this one. All right, there we go. Yep, that's the correct keyword. And then we got to do LEDs per strip, which would be the current length. Display memory, drawing memory, and config. All right, there's some new parameters here. It's an array of int 6 times the LEDs per strip. Interesting. All right. There's a couple options we got to do here. WS 2811 GRB, and then WS 2811 800 kilohertz. Whoops. There we go. Those look good. And then I think the the plus sign will work, but the appropriate ways to do an OR. Okay, and then finally, we basically have to create a buffer for it. I don't know if we've done that before. Just call it octo buffer. And then it's set to do the whatever the length times 6 is. I don't know why that particular thing is used, but seems pretty straightforward. All right. Drawing memory can be null. All right, And we don't have to specify the pin anymore because it always uses a dedicated pin, which is semi-interesting on this. All right, I think I got something wrong here. I think it just wants me to treat this as a global variable. Basically, inside that library is a global variable that we're going to use, which is kind of odd. But that's okay. Oh, no, wait. Never mind. It's the constructor. Okay. We'll call it strip so that we can use a lot of the same functions already. Begin. What else do we need? Basically, I need to find everywhere where this exists. Let's just set pixel. And then update pixels, and that's show. And it looks like there's a busy command. Because things are running kind of in the background on this. So I can do a while strip. So we wait until we're done, and then we do the next one. Then we'll show. Interesting. I wonder why if you have to create... Well, I guess they're based off size. Sorry, just talking to myself. And then you can also get a pixels color because it's saved in its own memory. Then if we comment that out, supposedly everything works. We'll change that to 2. Okay, what did we miss? Octo buffer was not declared in the scope. Yes, it was. Array bound is not an integer. Oh, it has to be a constant. That's why it doesn't like that. You can't just define globals like that and not have it be, and let it be dynamic, at least without certain parameters. White space after the macro name. Where's that? It's never thrown that warning before. Temp buffer size. Do we use that anywhere? Nope. That's why that's never thrown an error before. All right, validate that again. Hold on, we got another warning. I just want to make sure we don't mess anything up here. Or maybe used uninitialized in this function, probably because we never actually use it. That's fine. Okay. so let's plug this in. Hopefully nothing explodes. We'll upload this. All right, done uploading. And then I need to plug in my lights here. And then I got to plug them in over here as well. Just a sec. Okay, they are on. Make sure nothing's burning up. This feels pretty good. I don't know if it seems to be connected properly though, because if we go here, you can see some of them are lit up down here, and that's kind of weird. Something weird is going on there. All right. And I guess you open this. All right, we got the ready. I've forgotten completely how to use this, but that's okay. I think we have our Python script exactly for this, so let me pull this up. Yep. I'll just open it in PyCharm. All right, apologies. We're going to open this up real quick. If this works on the first try, I'll be stunned. I don't think it's going to, though. I think there's probably things about this library, being that it's the whole, like, eight strips at once library, that things are a little weird. And I don't know that everything's going to work. Like, everything's going to go to the lights that I think they go to. But I'll settle for seeing any of them do anything right now, just to prove we have communication. All right, let's close that. What are we running in our main here? Quick display. I think that's probably acceptable. I don't remember what that does. Just so you can see it, everything's in here. Waiting for everything to update on all the paths and generate the program. All right. Let's see if we get anything out of this, I guess. Could not open. Oh, I already have the serial port open. That sucks. All right, try again. Could not open port. Oh, it's on a different port. I don't remember which one it's on. Here, Teensy will tell me. Tools. Serial. COM5. Okay. I'm going to unplug this and plug it back in, because it's going to wait for me to start anyway. And then we need to change this to COM5. Okay. So technically it's doing something, but obviously it's not controlling the light. So something is still wrong. But I don't know what. Just make sure we're getting to where I think we're getting. We are not. Okay, so something is not quite working right. Because our script here is not even doing anything. I suspect that this is not running. I suspect we're getting stuck waiting for something. Controller begin. It's true. Odd that it tries to auto-detect the port. We might have to do this manually just to get started. Unfortunately, this, unlike the other device, ready. This one does not reset whenever you replug in the device. Length and color. Let's just go ahead and type this out. Init. Length is 21, and color. Let's do something so we can see it all work. Let's just light them all up. Why not? All right. Bring this over here and try it. Command received, nothing happened. I think. So that means our circuit's not quite working correctly. That's frustrating. But that's okay. It's kind of hard to tell exactly what's going wrong in these scenarios. Could be any number of stuff. Let me just double check that you think I'm using this library correctly. I suspect that I'm doing something either my ground connection's not very good over there. I might try and fix that real quick, actually, because that's something that needs to be working. Apologies real quick. Okay, I think I got that better. Yep, seems more solid. We're not having the flickering. All right, let's start over here. All right, so we'll drop the init. 21. I think I mistyped the format on that the first time. All right. Nothing. So there's something wrong with our data. Let me make sure I got those level shifters right. It's entirely possible they need a pull down, not a pull up. That would be really funny if I got that wrong. I think this mirrors, there's a SparkFun board that is very similar to the ones I bought that I can probably go off of. The bidirectional logic converter. Powered for the 2 voltages. Pin, low voltage LV pin, ground system, from the system to the ground pin. So okay, whatever board I'm using is basically a copy of the SparkFun one. I'll put this on screen so that we can see, you all can see what I'm looking at. Features, documents, hookup guide. I was just hoping for a picture. So it already has the pull-ups in the forms of 10K, so that's not doing anything. Through some semiconductor magic. That's what it, electronics are just magic. Remember that. I wonder if possibly the 2 ground lines should be connected to each other just to ensure an equal. It's not that hard to do. But it looks like I don't need these pull-up pins that I have on here. So my guess, it looks like I've got this connected up pretty good. I'm guessing what's probably happening is that my Teensy is not actually sending out the data like I think it's supposed to be, like I think it's doing. That's okay, though. This at least makes me feel better that I'm using this correctly. Sanity check to make sure I'm plugging these things into the correct thing. I2C. It gives you examples how to hook this up. Ground. It doesn't say anything about the grounds being connected to each other. So they might already be that way on the board. Alright, well, let's give it a shot then. Just make sure all this is still plugged into power. Yep, looks like it is. Nothing. Oh, wait. I think I have to tell it to show. What is that command again? It might be working properly and I'm just being dumb. Update. That's right. There's a command for updating. Okay, still nothing. So I think the init should have auto updated though, so I'm still missing something. If it's not with that, it's likely with the Teensy then. So something with this Octo library I'm not doing correctly. I need to see a better explanation of how exactly it works. Thank you all for hanging with me. Strip length goes strip length -1, so that's not the big deal. Okay. It's looking like I think I'm using this correctly. Oh, weird. They specify something in the memory here that I might want to as well. Let me make sure I'm on this. Yep. Okay. Whoops. Don't need that one anymore. Here. In their example, EMA. I wonder if this is like a volatile type constant or something that tells it basically don't mess with this. Verified. All right. Upload. Ready. Okay. Init. 1. Nothing. Still nothing. Alright, so that didn't fix it. What else am I missing? I wonder if this library... I don't think this was a thing. I think I read somewhere that you could still use this library. So even though the library is called the 2811, the LEDs I have are the 2812s, but I think they're cross-compatible. Like in terms of like this library can do both. Okay, yeah, it says here that you can absolutely use with the 2812 LEB, because the 2812B requires 5 volts. Okay, that makes sense. So I'm just missing something. All right, well, we did get a lot done. I'm not ready to call it quits just yet, but there may not be a lot more we can do here. I might just have to play around with the sum outside of this and see if I can figure out how to make it work. There's some cool stuff in this article that I'm reading where they're using it to make basically an entire TV display. We don't need anything near that complicated. Hmm. Only 8 fixed pins. Oh, interesting. Looks like the Teensy 4, you can use pretty much any pin according to this. But it doesn't give an explanation. Okay, so there's an example here. Examples. Teensy 4 pin list. All right, this is interesting. Evan GRB. I should try this one real quick. Because if this doesn't work, then that means there is something up with my wiring that's probably messing this up. Oh, okay, so it's something with my programming, because apparently... Hey, it works! Yay! What am I doing wrong? All right, well, look. At least... the whole time I'm going on about how it's the wiring and then how I'm not setting up pins correctly or something and all that. But actually, you can see all the lights are working fine. I was flipping through all of violet, yellow, blue or white. That's white. Red. Okay. So what am I missing? Set pixel, show, wait. Is there anything I'm missing in the setup? I call begin. All right, so look at this. Yeah, it does. It looks awesome. It's just, I wish it would look awesome with me controlling it. But you're absolutely right. It looks great. It's cool to see it all working because it means that we're really dang close. Okay, so I'm doing the begin. Maybe when I start, I have to immediately call show. Oh, I got to go through here and find the command again. Command set one, set mini, delay, set max init. Init calls NeoPixel init. What am I missing? Here it is. IK init, LK init. Thank you, book. It is cool. The purple and the yellow is kind of a cool color. I'm just more excited to see the whole thing working for like what was essentially $35 in parts. So half the cost of this board. So we don't update pixels when we do the init. So we do have to call update pixels, but maybe, maybe we do have to just immediately say strip begin, strip dot update, or show. Show is the, am I using that elsewhere every time I show it? Yes. It's also possible that this is always returning something. All right, let's verify this. There's only so many times we can do all this. All right, upload it. All right, starting from the beginning. Did it not upload? I must have just compiled. Upload. There it is. Ready? All right, init 21. Okay, they immediately go black. So it's definitely doing something. And then if I call update, still doesn't do anything. Let's do set, hold on. Set 1. And we'll do number 5, I guess. That'll be somewhere in the engines. And then we'll call update. Because maybe that first color is just getting screwed up. Okay, so that's on. So the first color we're doing is just getting messed up. So everything's working. It may just be weird. All right, then let me go back here to the main too. I want this to wait until setup right ready response. Okay, so this works a little differently than the other one does because it doesn't do that reset. So we need to actually wait for the serial port to start. And I probably have looked at an example that shows that. All right, while not serial. Quick and dirty, we'll have to change this loop next when we do the SD card. If we don't do the SD card, we basically want it to check for the serial port for like 5 seconds and then time out and say, okay, I didn't find one. Let me go to running the file. All right, let's validate this. Upload. And then we will try and run our Python script. Oh. Hey, it's working. Okay, cool. Let's pull this up. Okay, so we could see the engines are lit up, the underglow's working, and then does it just run that once? Yeah, and then it fires the lasers as well. Okay, cool. So we have proven that we've gotten everything back to where we started at, which is fantastic. And way more than I expected to possibly get done tonight, which means next time we need to do the SD card edition, which has already existed, and we've proven earlier today that it works. So we'll have to figure out like how we're going to store everything in the files and handle all that, but it should be pretty straightforward. Yeah, and I'm thinking too, what we'll do is just do basically a text file where each line is a command, and then we'll just read from the files one line at a time, and run that command, and just do that through the whole file, and then start over. So that way, it uses the same commands that we're using on the interface, except it's just written out in a file. That shouldn't be too hard to do. I think I can adapt that in the code fairly quickly, and we'll go from there. And then we'll have to figure out a way to test it out. Basically, run this and create a mode where we create a file for it or something. There's a lot of ways we could do that, but that's cool. All right, so we're showing that it works. Let me go ahead and run through the other stuff. So just so you can see what I'm doing here, I'm going to take out this quick display, and we're going to run through the whole everything that exists so far. All right, let's run this just to prove that it all works. Everything looks good. Oh, it might not run again. I might have to unplug it and replug it back in because it's not going to throw out that ready if the SD card is not there. Yep. All right. Try one more time. All right, it's going. I'll bring this up full screen so you all can see. But it looks good. Everything looks like it's running. Yep. Engine dies. Engine's going to restart. And then I think fire lasers maybe? Yep, there they are. Okay. Well, cool. I'm glad this worked without me having to debug a lot of things. And then landing lights are up. Yep, that's cool. And the engines turn off. Awesome. Everything looks good. We can figure out how to pack that in there. That shouldn't be that hard. And then I still need to get some hot glue and fix everything, so it's all in the right spot. Should be doable, though. All right. Well, I think that's going to be it for tonight. Thank you, everybody, for tuning in. I really appreciate it. I know this was kind of a long, drawn-out one with a lot of excitement. We were just trying to get everything back to where it was, but now we're in a spot where we can use the SD card. And once that's done, this project's going to be finished. We're going to have figured out a method to make a modular lighting kit system that we can use for just about anything. There's some other things I wanted to do software-wise, but I've got some other requests online. I've actually received a project request from one of our users, or one of the followers on this channel, and it looks like a pretty cool one. So I'll give you a hint ahead of time here. We're going to be making our own custom MIDI controller, with the volume knobs and everything for controlling sound. And so we're going to be using probably a lot of the same stuff that we did before. We won't use the lights, obviously. It's going to be doing something completely different. But we're not only going to be engineering this circuit and putting it in something, but we're going to be engineering an entire device that can plug into your computer and that you can use for sound mixing. So that should be cool. But anyways, thank you all for joining me. Thank you all for offering your help tonight, and I will see you all on Thursday. Have a good night.